When he publicly admitted that he had almost destroyed his own factory through over-automation, few people expected that this admission would become the starting point for the most radical manufacturing revolution in the history of the automotive industry. Elon Musk suffered a very public failure, and it was from that failure that a system was born capable of assembling a car in 40 seconds. For more than 100 years, the automotive industry operated on the same basic model. Thousands of individual parts are manufactured independently of one another. Then hundreds of robots weld them together. Then thousands of workers assemble each component step by step until a finished car finally rolls off the line. Toyota, Volkswagen, Ford, General Motors, all of them followed this logic for decades, gradually refining the same fundamental formula. Musk looked at this process and asked one simple question. If dozens of small parts ultimately get joined into one large assembly anyway, why produce them separately in the first place? Why stamp, then weld, then inspect every seam, when you could get a finished part in a single cycle? That question set off one of the largest manufacturing transformations in the modern history of the auto industry. But before it could happen, Tesla had to go through a painful failure. In 2018, in the middle of Model 3 production, Musk set a target of 5,000 cars per week. To hit it, he decided to automate the factory more aggressively than anyone in the industry had ever dared. Robots were assigned tasks that had traditionally been done by people: routing wiring, installing interior components, transporting parts between workstations. On paper, it looked like the perfect strategy. In practice, everything went wrong. Robots handled rigid, precisely positioned parts just fine. But the moment soft, flexible materials entered the picture, wire harnesses, insulation, problems started. The slightest shift of a component by a few millimeters would cause the entire downstream chain of operations to fail. The line would stop. Thousands of unfinished cars sat on the factory floor waiting for parts that sometimes had to be shipped in from overseas. Musk later wrote about it openly. Excessive automation at Tesla was a mistake. To be precise, it was my mistake. Humans are underrated. It's one of the rare occasions when he publicly admitted he had chosen the wrong path. But that failure gave Tesla one of its most valuable manufacturing insights. Robots are not the goal. Efficiency is the goal. If a human can do a task faster, cheaper, and more reliably than a multi-million-dollar robotic system, there is no point in automating that process. From that point on, Tesla began building its production around a different principle. Robots do what they are objectively better at than humans, and humans handle the work where flexibility, adaptability, and real-time decision-making matter. It was in this context that the technology that changed the rules of the game emerged. Instead of welding dozens of metal stampings together to form a car's frame, the way traditional manufacturers do it, Tesla began using massive casting machines called the gigapress. Depending on the vehicle model, these machines generate clamping forces of 6,000 to 9,000 tons, and the next generations of the equipment are reportedly expected to exceed 50,000 tons. In a single cycle, such a machine turns molten aluminum into one unified single-piece casting. Dozens of individual components and hundreds of welds are replaced by a single structural element. The impact of this decision ripples across the entire production process. At Tesla's factory in Texas, more than 1,000 robotic welding arms were in operation before the gigapress was introduced. After BOIS, the company was able to remove roughly half of them. Fewer joints means fewer potential defects. A simplified process means shorter production time, lower cost, and a fundamentally different pace of vehicle output. This is exactly the kind of innovation that buyers barely notice, but it directly affects the final price of every car. However, the gigapress is just the first element of Tesla's new manufacturing architecture. The next step is called the unboxed process. A traditional assembly line is linear. A car travels through hundreds of meters of line where each component is installed sequentially, one after another. Tesla is proposing a fundamentally different logic. The car is divided into 6 independent modules. The front body section is assembled in one area, the rear in another. The battery pack is produced on a separate line. The interior is fitted in parallel at its own station. All modules are built simultaneously and joined only at the final assembly stage. According to Tesla, this system can cut manufacturing costs by 50%, reduce factory floor space by 40%, and increase throughput by 30%. If those numbers hold up in practice, the cost gap between Tesla and other automakers will become nearly impossible to close. The first vehicle planned to be built under this system is the Cybercab. According to Musk, the target production cost is around $30,000 per unit, with the potential to come down further as the process scales. A full launch of the system is expected around 2027. While the new system is still being refined, the Gigapress is already running in tandem with one of the most technologically dense areas of the factory, the body shop. The body shop is often called the heart of production. This is where automation reaches its highest level. Unlike final assembly, where humans and robots work side by side, the body shop is almost entirely given over to machines. Hundreds of robotic arms operate around the clock, performing thousands of operations on each body. Every movement is programmed, synchronized, and timed to the second. This is where it's easiest to understand what Musk meant when he called the Tesla factory the machine that builds the machine. Tesla doesn't rely on a single method for joining parts. Resistance spot welding locks sheet metal together at thousands of critical points across the entire body. Laser welding is used where exceptional precision is required. It produces a cleaner seam, greater strength, and a more refined result. In addition to welding, high-strength structural adhesives of industrial grade are used, which significantly increase the body's torsional rigidity and reduce vibration. This combination of technologies is one of the reasons Tesla vehicles consistently earn top scores in crash tests. The main advantage of robots in the body shop isn't speed, it's repeatability. Even the most skilled technician will inevitably introduce minor variations after several hours of continuous work. A robot repeats the same motion thousands of times without any loss of precision. That means every body leaving the shop meets the same quality standard. After the body shop, the car moves into the paint shop, one of the most demanding areas of the entire factory. Here, even a microscopic particle of dust can ruin a finish and send an entire body back for rework. Temperature, humidity, and air cleanliness are controlled with surgical precision. The process begins with a thorough cleaning of the body to remove dust, grease, and production contaminants. The body is then submerged in an e-coat bath, cataphoretic primer coating. This method applies a uniform anti-corrosion layer to all metal surfaces, including hard-to-reach areas that a conventional spray gun simply can't get to. This is one of the key steps that ensures long-term protection against moisture, road salt, and corrosion. After priming, robotic systems apply the color coat, followed by a protective clear coat. Each layer is uniform in thickness across the entire surface of the body. The process is completed by curing in an oven at a precisely controlled temperature. An interesting detail that most people don't know: the paint shop is one of the few areas where several Tesla models move through a shared line before splitting off into separate assembly streams. For the Cybercab, an exception is planned. The color and protective coating are intended to be integrated directly into the casting process, eliminating traditional painting altogether. Competition in the automotive industry has long moved beyond arguments about range or acceleration. The real battle is over cost. Whoever can build a car more cheaply gains the ability to lower prices, capture market share, and keep investing in development. Tesla has demonstrated this strategy repeatedly, adjusting prices across different markets and putting serious pressure on competitors. If the new manufacturing system delivers on what it promises, the cost gap between Tesla and the rest of the industry could become structural and long-lasting. And it all started with admitting a mistake. With the moment it became clear that more robots doesn't mean better. Efficiency doesn't come from automation for automation's sake. It comes from a precise understanding of who, human or machine, will handle a specific task better. That principle is exactly what Tesla is building on today. If you're interested in following how engineering ideas turn into real production systems, hit like and subscribe to the channel. There's a lot more worth knowing ahead.